So before selecting, so the role of engineers is concerned with the producing and fabricating the materials to meet the requirement in the society. Even though there are so many number of properties which are said to be as the primary property like electrical, magnetic, optical properties and so on. The one of the important property is called as uh, mechanical property. Okay. In most of the applications, we are going to select some proper materials where it requires the ductile property. Some materials may possess the high strength, should require the high strength, and they should have the high brittle for some cases, and so on. So, in order to understand the materials, suitable materials to a particular application, first we should know the basic properties of the material. In which the mechanical property, we are going to study the elasticity property of the material. So, by knowing the basic concept of the elasticity, we can understand whether the material can withstand the high load or high pressure or not. For example, most of the materials involved are going to have the load when it is in under operation. Am I right? For the steel axle or chassis in the automobile industry and the aluminum alloys that are used in the aeroplane wings, they will be under the pressure or the loads are applied when they are in use. When they are in use. Now, in order to know it, we are going to have the study of the elasticity here. So, what is mean by elasticity? Now, let us consider a body or an object. Am I right? Where any external force is not applied to the material. Now, it is in the not deformed position here now. Not deformed position. Now, the force is applied to a object or a body. When a force is applied to a body, the body will start to move due to the force applied on it. Am I right? Suppose if the body is not in a moving position, if the object is not in the moving position, then what are the changes may occur there? There may be some change in the dimension of the object. Now let us consider that there is an object. We are going to give an external force to the object. Then the object will start to move due to the force applied on it. But when it is in a rest position, then if you give a force, instead of moving, they will start to show some deformation on it. The deformation which it takes place is true for all the materials, including polymeric material. The deformation will take place when a force is applied on it. The dimensional change that takes place in the body may be along the lengthwise or maybe change in the volume of the object without having a change in its size and shape, or the deformation may takes place in the shape of the object without changing in its volume. ஸோ ஒன்று ஒரு ஆப்ஜெக்டில் ஒரு ஃபோர்ஸ் கொடுக்கும் பொழுது அது என்ன ஆகும்? ஒரு பால் இருக்குது, பாலை எட்டி உதைக்கிறீங்க, the ball will start to move. Suppose if the ball is in the rest position, if you give a force on it, then what happens there? Some change in the dimension will take place. என்னென்ன மாதிரி டைமென்ஷன் சேஞ்ச் ஆகலாம்? ஒன்று அதனுடைய லென்த்து நீளலாம், இல்லைன்னா அதனுடைய சைஸ் மாறாமல் வால்யூம் டிக்ரீஸ் ஆகலாம், இல்லைன்னா சைஸ் அண்ட் ஷேப் மாறும், வால்யூம் அப்படியே இருக்கலாம். ஸோ இந்த மாதிரி ஏதாவது ஒரு சான்சஸ் தான் ஆர் தேர். Now when the deformation force which is applied on it is said to be as a compressional force, the shrinking in the size of the material may occur. Or if a tensile force is applied on it, it will elongate. So the length will increase again. Right. So the force which makes the material to undergo this deformation is called as the deformation force. So what is meant by the deformation force here? The force which produces the deformation to the object, which causes some change in its dimension. Then such type of the force are called as a deforming force. Due to the deforming force, if the material is having the ability to regain its original size and shape, to regain its original position, then that is called as the elastic material. Suppose if they are not able to retain their original position after the removal of the deformation force, and that is called as the plastic material, which causes the permanent deformation. So whenever an object is subjected to a deforming force, which causes some change in the size and shape of the material, there will be an equal and opposite force is also acting on the object, which makes it to bring back to its original dimension. Then such type of the forces are called here as the restoring forces. Am I right? So if the deforming force is removed from the object, the restoring force will act on the object so that the object can regain its original length or the shape or size. Now this property of recovering this original length or shape or size of the object after the removal of this applied force, that is the deforming force, are called as a elastic property. It's called as an elastic property. So the two different type of the forces are going to take place. One, the external force which acts on the body to undergo deformation. At the same time, the equal and opposite forces will take place within the body to regain its position. Now, the restoring force will be dominant when the deforming force applied is kept removed. If the restoring force makes the material to regain its original length, original size or shape, then they are a recoverable elastic material. If they are not able to regain their original size or the shape, which shows some permanent deformation within it, they are referred as the plastic materials, isn't it? Now, we are going to have the collision as an elastic collision and the inelastic collision. What is meant by the elastic collision? The elastic collision, the total momentum and the total kinetic energy both are said to be the same, that it remains constant here now. Right. The object which remains separate after the collision, the object can be kept separated after the collision. So they will have the collision, and then after the collision process, the objects may be kept separated. For example, the kicking a soccer ball with your foot. When a soccer ball is hit with your foot, the foot and the ball is having a collision. The total momentum and the total kinetic energy before the collision is the same as that of after the collision. After having a collision, the saucer ball will under the motion it will be move away. Am I right? So your foot and the saucer ball is now kept separated. Similarly, hitting a baseball with a bat, then in the billiards, hitting the ball with a stick, where the collision existing between the two objects going to have the momentum and the kinetic energy to be constant. Suppose if it is an inelastic collision, then how it will be? So in the inelastic collision, after having a collision, the two objects will stick together and move with a common velocity after having a colliding. For example, the arrow hitting a target. So if you, with the help of the bow and arrow, if you hit a target, the arrow will go and hit the target, and with the force which was applied through the arrow, the target will move to a certain distance and then fell down, where both the arrow and the target is going to be kept fixed with one another. Even after the collision, they are not separated. Then we have to separate manually. Similarly, the bullet lodging into a wooden block, or the meteorite colliding with the earth and becomes combusted. These are all having the collision between the two objects. After the collision, they will be stick with one another. But in the elastic collision, they will be kept separable, where the total momentum and the kinetic energy are said to be the same. This is an elastic deformation. In the elastic deformation, what happens there now? In the elastic deformation, the arrangement of the atoms of the molecules within the body will be in a regular manner. So when it is subjected to a pressure or a load or a force which is applied on it, the bond existing between the atoms will be kept stretched here now, which causes some change in its length. So there is a increase in the length of del. The force is applied at the bottom. So for that, let us consider there is a wire. The wire, one end of the wire is fixed at one point, and the other end is left free. We are going to apply the load at the free end. Due to the force which is applied at the free end, the wire is kept stretched here now, which makes the atoms bond existing between the atoms to be kept loosened, which causes some change in its dimension. If the force which is applied is kept removed, the force which is applied is now kept removed, which makes the atoms of the molecules to retain their original position, which causes the regain the original size and shape of the material here now. So initially what it is, that will be after that. Then that is called as the elastic deformation. So the elastic means that is reversible, where they can regain their original position, which shows the linear elastic here now. If it is the linear elastic, the stress is directly proportional to the strain. So whatever the force we are going to give, the changes will be take place. After the removal of the force applied, that will come back to the original position. That shows the linear elastic. If it is considered as a non-linear elastic, the force and then the regaining distance will somewhat differ, but it can regain the original position, but not as a proportional. The second next one is the plastic deformation. When the plastic deformation takes place, if the bond stretching and the shearing of the planes takes place when it is subjected to an external force and does not regain their original position by the atoms of the molecules, will causes a permanent deformation within it. The permanent changes may occur even after the removal of the external force applied. So the first diagram shows you the initial position where the atoms or the molecules are arranged at a particular point. Due to the load applied, the material is going to have a stretch in it due to the movement of the atoms or the molecules by changing in its bonds. And then after the removal of the force, it regain their or does not regain its original size and shape, which causes a permanent deformation of about del. Then that region is called as a plastic region. So that is the plasticity or plastic deformation which takes place. And the best example to understand the concept of the elasticity, the rubber band. So you are going to stretch the rubber band by applying a force by the help of your fingers. On both sides you are going to give your force, which makes the rubber band to have the expand in its length. Then after the removal of the external force applied by you, the rubber band can regain its original position. Am I right? Then that is called as a elasticity. And then for the plasticity, these are the some examples. If you crush the water bottle, after the crush which is made by you is removed, the force applied by you is removed, it does not regain its original position. It permanently deformed. And that is called here as a plastic material. So the materials can be classified into two types on the basis of this elastic property. One as an elastic material and another one as a plastic material. The materials that regains their original length or shape or size after the removal of the deformation force are called as a elastic material. The material which are not able to regain their original length or shape or size after the removal of the deforming force are called as plastic materials. Generally, there are no materials available which is going to exhibit the perfect elasticity or the perfect elasticity. Am I right? Now, these are the some basic definitions to be known. In the examination point of view, which will be asked as a 2 mark questions. Just all of you take your notebook. I asked all the students to put a separate notebook for physics. Am I right? All take your physics notebook and give the title of the subject as the engineering physics. You take your notebook. Write the subject name as the engineering physics. Okay. 15, Balamurugan J.
Yes, sir.
Can you unmute your video and show me the notebook, ma? Just unmute your video. First show me your face. So Balamurugan. From where you are? எங்கேருந்து வரீங்கப்பா? உங்கள் மைக் மியூட்லேயே அன்மியூட்லேயே இருக்குது பாருங்கள். மியூட்லேயே இருக்குது, அன்மியூட் பண்ணுங்க முதல்ல.
சிறுவாபுரி சார்.
அப்பா
சிறுவாபுரி சார்.
சிறுவாக்குடி அது எங்கே இருக்குது?
திருவள்ளூர்ல சார்.
திருவள்ளூர். இட்ஸ் ஓகே. தனியாக நோட் போட்டிங்களா?
எஸ் சார்.
சரி, ஓகே. இட்ஸ் ஓகே, ஃபைன். யூ கேன் மியூட் யுவர் வீடியோ. Write the title of the subject as the engineering physics. And the subject code is very important. So along with the name of the subject, write the subject code also as 191 PYB 101T. Title of the unit, Unit 1, Properties of Matter.
Can you repeat the number also?
என்னப்பா?
Subject code.
Subject code,
One
sir. One time repeat,
nine.
sir.
அதான்பா 191 PYB PY for physics, B for basic science, B 101 T, capital T, T for theory, 191 PYB 101 T. Under that, just you mark it down, the unit 1 properties of matter. பேசிக் சயின்ஸ் உங்களுக்கு இன்ஜினியரிங் ஸ்டடியில் இன்ட்ரடியூஸ் பண்ணதுக்கான ரீசன் உங்களுக்கு பேசிக் கான்செப்ட்ஸ் தெரிஞ்சிருக்கணும். நீங்கள் எந்த ஒரு மெட்டீரியல் எடுத்தாலும், எந்த ஒரு அப்ளிகேஷன் ஆஃப் த இன்ஜினியரிங்கில் போனாலும் உங்களுக்கு அந்த மெட்டீரியலோட ப்ராப்பர்ட்டிஸ் தெரிஞ்சிருந்தால் மட்டும்தான் இந்த மெட்டீரியலை இந்த அப்ளிகேஷனுக்கு யூஸ் பண்ண முடியும், இந்த மெட்டீரியலை இந்த அப்ளிகேஷனுக்கு யூஸ் பண்ண முடியும்னு தெரியணும். அப்படி தெரியலனா சூட்டபிளே இல்லாத ஒரு மெட்டீரியல் எடுத்து ஒரு அப்ளிகேஷனில் போட்டிங்கன்னா அந்த அப்ளிகேஷன் வேஸ்ட். நீங்கள் ப்ராசஸ் பண்ணுற மணி வேஸ்ட்டு, டைம் வேஸ்ட்டு, எல்லாம் வேஸ்ட் ஆகிடும். ஸோ as being a mechanical engineer and automobile engineer, before selecting a material, you should know the properties of the material to select the material for a particular application. அந்த ப்ராப்பர்ட்டிஸ்ன்னு பார்த்தீங்கன்னா ஏகப்பட்ட ப்ராப்பர்ட்டிஸ் இருக்குது. எலக்ட்ரிக்கல் ப்ராப்பர்ட்டி இருக்குது, மெக்கானிக்கல் ப்ராப்பர்ட்டி இருக்குது, மேக்னெட்டிக் ப்ராப்பர்ட்டிஸ் இருக்குது, பயாலஜிக்கல் ப்ராப்பர்ட்டிஸ், ஏகப்பட்ட ப்ராப்பர்ட்டிஸ் நம்ம ஸ்டடி பண்ணணும். அதில் ஸ்ட்ரென்த் ஆஃப் த மெட்டீரியல் நமக்கு தெரிஞ்சிருக்கணும் அப்படின்னா மெக்கானிக்கல் ப்ராப்பர்ட்டி வெரி இம்பார்ட்டண்ட். அந்த மெக்கானிக்கல் ப்ராப்பர்ட்டியில் எலாஸ்டிசிட்டி பற்றி அதிகம் தெரிஞ்சிருந்தால் மட்டும்தான் நம்மளால் என்ன பண்ண முடியும், அது எவ்வளோ லோடு தாங்கும் அப்படிங்கும். ஏன்னா நம்ம ஒரு மெட்டீரியல் எடுத்திருக்கோம், அதை எடுத்து ஒரு அப்ளிகேஷன்ஸில் யூஸ் பண்ண போகிறோம். யூஸ் பண்ணும்போதே அது மேலே நிறையா லோடு கொடுக்க வேண்டியிருக்கும், ப்ரெஷர் கொடுக்க வேண்டியிருக்கும். அது வந்து ஆப்ரேஷனில் இருக்கும் பொழுதே அதுக்கு சில ஃபோர்ஸஸ்லாம் அதை வந்து ஃபேஸ் பண்ணும். அப்போ நம்ம அந்த ஃபோர்ஸ் ஃபேஸ் பண்ணும்பொழுது அது எந்த ஒரு டிஃபார்மேஷனும் ஆகாமல் அந்த மெட்டீரியல் அப்ளிகேஷனுக்கு சூட்டபிளாகவே இருந்துட்டு இருந்ததுன்னா பிரச்சனை இல்லை. அப்போ அது தெரிஞ்சிருக்கணும்னா ஃபஸ்ட்டு யூ ஹேவ் டு ஸ்டடி த எலாஸ்டிக் ப்ராப்பர்ட்டி பற்றி தெரிஞ்சுக்கணும். ஸோ எலாஸ்டிக் ப்ராப்பர்ட்டினா என்ன? whenever a force is applied on a body, the body will started to move in a direction. ஒரு உதச்சனா ஒரு பந்து மூவ் ஆக தான் செய்யும். அதே அது பந்து மூவ் ஆகாமல் ஒரே இடத்துல இருக்குது அப்படின்னா என்ன ஆகும், அந்த இடத்துல சம் சேஞ்சஸ் மே அக்கர். ஒரு ஸ்ப்ரிங்கை என்ன பண்ணுறோம், ஒரு கையில் பிடிச்சிட்டு இன்னொரு எண்ட் ஆஃப் த ஸ்ப்ரிங்கை பிடிச்சி இழுக்கிறோம், நீங்கள் என்ன ஆகும், எக்ஸ்பேண்ட் ஆகும். ஸோ தட் இஸ் த ஃபோர்ஸ் விச் ஆக்ட்ஸ் ஆன் த பாடி டு ஹாவ் சம் சேஞ்ச் இன் இட்ஸ் டிஃபார்மேஷன். அந்த டிஃபார்மேஷனுங்கிறது சேஞ்ச் இன் த டைமென்ஷன். இந்த டைமென்ஷன் வந்து என்ன ஆகலாம், லென்த்தில் இருக்கலாம், சைஸில் இருக்கலாம், ஷேப்பில் இருக்கலாம், இல்லை வால்யூம் ஆஃப் த மெட்டீரியலில் இருக்கலாம். ஸோ ஏதோ ஒரு changes in the dimension takes place. The force which makes the material to undergo such a dimension change is called as the deforming force. ஸோ இந்த பேசிக் டெஃபினேஷன்ஸ்லாம் வந்து 2 மார்க் கொஷின்ஸில் வரலாம். ஸோ அதனால் இதை மட்டும் காப்பி பண்ணி எப்படி. ஸோ பேசிக் டெஃபினேஷன்ஸ்னு போட்டுட்டு deforming force. The external force which acts on your body that causes a change in the size or shape or both. அப்படின்னா அதுக்கு பேர் deforming force. So whenever there is a force acting on a body, the equivalent opposite forces may gained by that body, which will act on its body. அது எதுக்கு பண்ணும்? நம்ம கொடுக்குற ஃபோர்ஸை அதை அப்போஸ் பண்ணும். அப்போது நம்ம கொடுக்கக்கூடிய ஃபோர்ஸ் டாமினண்ட்டாக இருந்ததுன்னா சேஞ்சஸ் அதிகமாக இருக்கும். அதே நம்ம கொடுக்கக்கூடிய ஃபோர்ஸ் கம்மியாக இருந்துச்சுன்னு சொன்னால் ரீஸ்டோரிங் ஃபோர்ஸ் டாமினேட் பண்ணிச்சுன்னா ரீகெயின் பண்ண ஆரம்பிக்கும். ஸோ ஆஃப்டர் த ரிமூவல் ஆஃப் த எக்ஸ்டர்னல் ஃபோர்ஸ், நம்ம எக்ஸ்டர்னல் ஃபோர்ஸை ரிமூவ் பண்ணிட்டோம். அப்போ என்ன பண்ணும்? அந்த ரீஸ்டோரிங் ஃபோர்ஸு அந்த மெட்டீரியலை அதனுடைய ஒரிஜினல் சைஸ் அண்ட் ஷேப்புக்கு கொண்டு வரும். Now the restoring force is acting in a direction that is opposite to that of the deforming force. So that here it is indicated with the help of the negative sign. The negative sign indicates that the force is acting just opposite to that of the deformation force. So F is equal to minus K into X, where K is called as the restoring force constant. நம்ம எந்த அளவுக்கு நம்ம ஃபோர்ஸ் அதை ரீஸ்டோரிங் ஃபோர்ஸ் அதிகமாக தேவைப்படும்னா எந்த அளவுக்கு நமக்கு எலாங்கேஷன் ஆகிருக்கோ அந்த அளவுக்கு தேவைப்படும். இப்போ 1 சென்டிமீட்டர் தான் எலாங்கேட் ஆகிருக்குன்னா அந்த 1 சென்டிமீட்டருக்கு தேவையான ரீஸ்டோரிங் ஃபோர்ஸ் தான் தேவைப்படும். 5 சென்டிமீட்டர் எலாங்கேட் ஆகிருக்குன்னா அப்போ அந்த 5 சென்டிமீட்டருக்கு தேவையான ஃபோர்ஸ் என்ன ஆகணும்? அதுக்கு ரீஸ்டோரிங் ஃபோர்ஸ் தேவைப்படும். ஸோ த ஃபோர்ஸ் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு த டிஸ்டன்ஸ் ஆர் த டிஸ்பிளேஸ்மெண்ட் ஆர் த சேஞ்ச் இன் லென்த், வாட் எவர். So the force which restores the size and shape of the body when the deformation forces are removed, F is equal to minus K into X. The F is directly proportional to X, where F is equal to minus K into X, where K is the proportionality constant. Here it is referred as a restoring force constant, and the negative sign indicates that the restoring force is acting in a direction that is opposite to that of the deforming force. The next one is a rigid body. The rigid body is a solid body where it does not undergo any change in its shape and size even though the large force is applied. அதுக்கு பேர் தான் ரிஜிட் பாடி. ஆனால் ரிஜிட் பாடிங்கிறதுக்கு பர்ஃபெக்டான ரிஜிட் பாடி நேச்சரில் கிடையாது. ஓகேவா? There will be some small change. The change may be as some negligible amount. Am I right? There will be some change in it, within it, but that will be in a negligible amount. So generally the rigid body is defined as a body whose shape and size that cannot be changed. So by having the application of the external force, even though it is said to be as a large force. Shall I move to the next slide?
Yeah, 1 minute.
The examination point of view la defined restoring force nu kekkalam, illa what is mean by rigid body nu varalam. During the lecture session, just I will indicate some certain portions which will be asked as a 2-mark question. It will be asked as a 8-mark question. It will be asked as a 16-mark question. நான் அப்பப்போ உங்களுக்கு இன்ஃபார்ம் பண்ணிடுவேன். ஓகேவா? இப்போ நீங்கள் அதுக்கு தகுந்த மாதிரி அந்த சைட்லேயே 2 marks 16 marks 8 marksனு ஏறிக்கின்னு நாளைக்கு உங்களுக்கு ப்ரிப்பரேஷனுக்கு யூஸ் ஆகும். Even though we will supply a question bank, நீங்கள் படிக்கும்போது இதுக்கு எவ்வளோ இம்பார்ட்டன்ஸ் கொடுக்கணுங்கிறது உங்களுக்கு தெரிஞ்சிடும் வெயிட்டேஜ் ஆஃப் த மார்க்ஸ் வச்சு. Okay, move பண்ணலாமாப்பா?
Sir, for restoring force, the value will always be negative, sir. Minus K.
புரியலப்பா. Restoring force?
The value, sir, always will be negative, sir. For restoring force.
Yeah, the restoring force ஏன் அது நெகட்டிவ் இண்டிகேட் பண்ணியிருக்கோம்னா
இழுக்கிற
டிஃபார்மிங் ஃபோர்ஸும் ரீஸ்டோரிங் ஃபோர்ஸும் ஆப்போசிட்டுங்கிறத தெரிவிக்கணும்ல. டிஃபார்மிங் ஃபோர்ஸ் வந்து லெஃப்ட் டு ரைட்ல நடக்குதுன்னு சொன்னா ரீஸ்டோரிங் ஃபோர்ஸ் ரைட் டு லெஃப்ட்ல போகும்.
ஓகே சார்.
அப்போ அது ஆப்போசிட் டைரக்ஷனில் நடக்குது அப்படிங்கிறத தெரிவிக்கிறதுக்காக அந்த நெகட்டிவ் சைன் போட்டு காட்டுறோம்.
தேங்க்ஸ். தேங்க்யூ.
சார் ஆனா இதுவே இப்போ ஒரு நசுங்கின பாட்டில ரீஸ்டோர் பண்ணணும் நம்ம நசுக்கி தானே சார் ஒரே இதுல கொண்டு வருவோம். அதனால அப்போ மைனஸ் மைனஸ் பிளஸ் ஆயிடும்.
இல்லை உங்களுக்கு இது நான் பேசுறது வந்து எலாஸ்டிசிட்டிக்கு மட்டும் தான் நம்ம பேசுகிறோம்.
எலாஸ்டிக்
அது பிளாஸ்டிசிட்டியில் உங்களுக்கு ரீஸ்டோரிங் ஃபோர்ஸ் ரொம்ப லோவாக தானே இருக்கும். அதில் ஒரு பிளாஸ்டிக் பாட்டிலை க்ரஷ் பண்ணோம்னா that does not regain its original position. But a little bit amount of the restoring force will act on it. That also going to be in a opposite direction. So that is applicable for the plastic material also.
Yes.
But the F is directly proportional to X ங்கிறது elastic material perfect பொருந்தும். Plastic material அது பொருந்தாது.
F is directly proportional to X சார் அந்த எலாஸ்டிசிட்டில.
என்னப்பா?
எலாஸ்டிசிட்டில F is directly proportional to X சார்?
Yeah, elasticity materialக்கு F is directly proportional to X.
Okay.
Okay, move to the next slide. The elasticity. The elasticity is one of the property which is going to give an idea of about the regaining of the original size and shape of the material after the complete removal of the external forces. That is a deformation force. நம்ம அப்ளை பண்ணக்கூடிய டிஃபார்மேஷன் ஃபோர்ஸை கம்ப்ளீட்டாக ரிமூவ் பண்ணதுக்கு அப்புறமா அந்த மெட்டீரியல் அதனுடைய ஒரிஜினல் சைஸ் அண்ட் ஷேப்பை ரீகெயின் பண்ணுச்சுன்னா அந்த ப்ராப்பர்ட்டிக்கு பேர் எலாஸ்டிக் ப்ராப்பர்ட்டி ஆர் எலாஸ்டிசிட்டி. அந்த பாடிக்கு பேர் எலாஸ்டிக் பாடி. அண்ட் தென் த பிளாஸ்டிக் பாடி ஜஸ்ட் ஆப்போசிட் out to that of the elastic nature. The material does not regain its original size and shape after the removal of the deforming force. ஒரு டிஃபார்மிங் ஃபோர்ஸ் அப்ளை பண்ணதுக்கு ரிமூவ் பண்ணதுக்கு அப்புறமா அதனால ஒரிஜினல் சைஸ் அண்ட் ஷேப்புக்கு வர முடியல அப்படின்னு சொன்னால் அதுக்கு பேர் என்ன? பிளாஸ்டிக் பாடி. எக்ஸாம்பிள் ஃபார் த பிளாஸ்டிக் பாடி clay, mud, wax, lead, chewing gum. These are all the some simple example for the knowing of the plastic body. The elastic bodyக்கு நமக்கு தெரியும். Best example is the rubber band. Okay, shall we move to the next?
Yes, sir.
Okay, these are all the some, yeah. Just to make it fast. Okay. Now this part of the question will be asked as a 2-mark question or a 4-mark question. If it is asked as a 2-mark question, what are the factors that may affect the elastic nature? அப்போ என்ன பண்ணுவோம், நீங்கள் வந்து இந்த டைட்டில் மட்டும் கொடுத்தா போதும். எஃபெக்ட் ஆஃப் ஸ்ட்ரெஸ், எஃபெக்ட் ஆஃப் டெம்பரேச்சர், எஃபெக்ட் ஆஃப் இம்ப்யூரிட்டிஸ், எஃபெக்ட் ஆஃப் நேச்சர் ஆஃப் த கிறிஸ்டல், அந்த எஃபெக்ட் ஆஃப் அனிலிங், இந்த மாதிரி ஒரு டைட்டிலை மட்டும் கொடுத்துட்டிங்கன்னா அது ஒரு 2-mark கொஸ்டின்ஸுக்கு சூட்டபிள். If the same is asked for a 4-mark question, then you have to explain the each and every factors here now. So elasticity ங்கிற ஒரு nature, how it was kept affected. What are all the factors are influenced to change the value of this elasticity? Now the material is there, that's having certain elastic nature. The elastic nature of the material is going to be kept altered by means of some factors. எப்பப்பெல்லாம் அது வந்து மாறும்னு கேட்குறாங்க. So by means of the cyclic stress. When a repeated stress is applied to the material, what happens here now? For example, let us consider the railway track. The iron rod is having a certain elastic nature, and the train is made to rail over the rail. The train is made to run over the rail. If it is done for 2 or 3 times, okay, no problem. It will regain its original size and shape and have the elastic nature as it is. If the train is made to run over the rail frequently, then what happens then now? For 100 times or 1000 times or 10,000 times, it may have the ability to regain it. If the stress is repeatedly given to the particular material, the material started to lose its elastic nature, The material started to lose its elastic nature. So, upon the repeated stress which is given to the material, that causes a decrease in the elasticity of the material. So, it started to lose its elasticity. So, within the elastic limit, if the material started to lose its elastic property by means of this cyclic stress, then that is called as fatigue. So, நம்மளே கூட பேசிப்போம் ஒரு ஃபெட்டிக் ஆயிடுச்சு அப்படிங்கும். வாட் இட் மீன்ஸ் தட் இஸ் அண்டர் த ப்ரெஷர் மோர். ஆமா ரைட். இப்போ நீங்கள் வந்து ஒரு ஸ்டூடெண்ட் இருக்கீங்க, ஒரு ஸ்டாஃப் இருக்காங்க, ஜஸ்ட் யூ ஆர் கமிட்டிங் எ மிஸ்டேக். ஸோ த ஃபேக்கல்ட்டி இஸ் அட்வைசிங் யூ or your parents are advising you. For 1 or 2 times you are ready to bear their advice, but repeatedly if I advise you, am I right, what happened to you? You will cause some irritation, just you will lose your temper. That's the elasticity is decreased. The same way, if the stress is repeatedly given to a material, the material started to lose its elastic nature. And then the effect of temperature. The increase in the temperature generally decreases the elastic property of the material. For example, the elastic property of the invar steel is not affected by the temperature, but the carbon, lead, or some materials. Upon increasing in the temperature, the bond existing between the atoms may be kept disturbed. Due to the thermal agitation, the bond will be kept broken, which causes some change in the material. That shows a decrease in the elasticity of the material. And then effect of impurities. Depending upon the requirement of the change in the elastic value of the material to a particular application, sometimes we need the high elasticity, sometimes we need the low elastic nature of the material. So in such a case, by means of adding some impurities, we can alter the elasticity. Thus, depending upon the impurities that are added, the elasticity nature of the material may increase or decrease. For example, let us consider the gold. By having a pure gold, we can't make any ornament. By having the 24 karat gold, we can't make any ornament because it shows high brittle nature. Am I right? Kira potal damun odayum. So by having this, we can't make any ornaments. We can't make it to bend here now. Bend பண்ணாலே அது என்ன ஆகிடும், பிரேக் ஆகிடும், 2 பீஸ் ஆகிடும், 3 பீஸாக உடஞ்சிடும். அப்போ என்ன பண்ணணும் அந்த இடத்துல, you have to increase its ductile nature, that is elastic nature increase பண்ணணும். So for that we are going to add some copper within it. So addition of the copper is an impurity now. The copper is added with the gold in order to enhance the elastic property of the material. After that, it will not be as a 24 karat, it will be as a 22 karat. Nowadays, they are calling it as a 916. ஸோ அந்த ஃபார்முக்கு வந்து கொண்டு வந்ததுக்கு காப்பர் ஆட் பண்ணதுக்கு அப்புறமா அது என்ன பண்ணுவோம், கொஞ்சம் வளைஞ்சு கொடுக்கும் தன்மையை இன்க்ரீஸ் ஆகிடும். ஸோ இஃப் இட் ஷோஸ் தட் சச் டைப் ஆஃப் த எலாஸ்டிக் நேச்சர், we can bend into any desired shape without causing any crack or damage. We can bend into any desired shape where we can make an ornament. Am I right? Similarly, the carbon is added to iron. Carbon is added to iron in order to enhance the elastic nature of the material. So the impurities may either increase or decrease the elastic property of the certain metal. So if the impurities has more the elasticity, then the material to which is added, that also increases the elasticity. அதே impurity add பண்றதுக்கு வந்து less elasticity property தான் இருக்குன்னா, that causes a decrease in the material here now. So the raw material oda elasticity வந்து இன்னும் further குறைச்சிடும். So the increase or decrease of the elasticity of the material depends upon the impurities that are added. And the next one is the effect of nature of the crystal. The effect of nature of the crystal. If the crystal is having a single crystal, the single crystal means it consists only one domain within it. So in which all the atoms are going to be oriented in a same direction. Am I right? That shows a very less elasticity nature here now. That shows a decrease in its elasticity because all are in the same direction. So when a force is applied, they will react in the same direction, which does not give a flexibility here now. So that there will be a decrease in the elastic nature of the material. The next parameter is known as the effect of annealing. In the effect of annealing and the hammering and the rolling will give you the material to have the break in the bonding of the material, which causes an increase in the elastic property of the material. If it is said to be as annealing is what is meant by annealing? It is a process of changing the temperature. That is a process of heating. Quenching means a sudden cooling. Annealing means some change in the temperature here. Now the process of heating the material to a particular temperature, and then we have to cool it gradually. That is the annealing process. If the material is taken to the higher temperature and it is kept cooled suddenly, then that is called as a quenching process. Now during the annealing process, the particle size will get increased and the material will become as a hardened, so that the elastic property will be kept reduced, similar to that of the single crystal what we discussed in the previous point. So by having the nature of the crystal as a single crystal, the elastic property will be kept decreased. During the annealing process, when you are cooling down very slowly and gradually, all the atoms and molecules will go and occupy their position in a perfect manner to form a large sized grain here now. Am I right? That is the domain. So in which all the atoms or the molecules are going to be having the similar orientation. So in such a case, the elastic property will be kept decreased because they are going to have the high hardened property. In the case of effect of hammering and rolling, due to the pressure applied during the hammering, that reduces or divide that large sized grain into the small sized grain, that will increase the elastic property of the material. So these are all some factors that may affect the elasticity. Due to the repetition of the stress applied on the material, that is a cyclic stress, the elasticity decreases. So the decreases and the increases is indicated with the help of the arrow mark for our convenience. The effect of temperature changes the material to show the decrease in the elasticity. And the effect of impurities that are added may increase or decrease that depending upon the impurities that are added. If the impurities are having the high elastic nature, the material will have the high elastic property. And if the impurities that are added are having the low elastic nature, then the materials may have a decrease in its elasticity. And then the nature of the crystal. If the material what we have taken is having a single crystal, which does not contain any further domains, then that shows a low elasticity. And during the annealing process, upon cooling very gradually and slowly from the higher temperature, then the material will form a large sized grain within it, which leads to a decrease in its elastic nature. And then the same can be hammered or rolled, that causes make a division of that large sized grain into the small sized grains further. That increases the elastic nature of the material. Am I right? So these are all some factors that may affect the elasticity. If the elasticity property is lost within the elastic limit due to the repeated stress which is applied on it, then that forms a fatigue here. Now that's called as an elastic fatigue. So apart from that elastic fatigue, these are some factors that may affect the changes the properties of elasticity in the material. So okay. So with this I conclude this session today. So far I discussed that what is meant by elasticity, what is meant by the plasticity. To have the elasticity, the material should reach its original size and shape after the force which is applied is removed. The force which acts on the body to form the change in the size and shape is called as the deforming force. And the equal and opposite force acting on the body to regain its original size and shape is called as the restoring force, where the restoring force is directly proportional to the displacement of the changes. Am I right? So depending upon the changes, the force which acts on the material also depends. Based upon that, the material can regain its original position. If it's directly proportional, that is elastic property. If it is not directly proportional, then that will become as a plastic material here now. So what is meant by the deforming force? What is meant by the restoring force? What is meant by the elastic material? What is meant by the plastic material? What is meant by the elasticity phenomena? And what is the plasticity phenomena? How these elasticity phenomena can be kept altered in a material? What are the factors that may affect it? So far we have discussed some basic definitions of the elasticity of the material. So in the next class we are just entering into the parameters stress, strain, and based upon the stress and the strain, what are the different type of the stresses are available, what are the different type of the strains are there, and by having the ratio